Chuck out another explainer.
Awesome.
The diameter of the sun.
Okay, this sounds boring.
The diameter of the Earth is about 8,000 miles. And
Thank you. And that's it. Because did not know that, so I'm already good.
It's about 8,000 miles.
About 8,000 miles.
Okay. And from that, you can know the circumference, if you remembered pi.
Okay.
The circumference equals pi times the diameter.
Okay.
And how much is pi?
3.14 something.
Exactly. So a little over 3.
Right.
So you multiply 8,000 miles times 3 and a little bit, you get at least 24,000 miles around and some change. It's about 25,000 mile circumference.
Right.
Okay, fine. And I think we did on a separate explainer that the diameter of Earth pole to pole is less than the diameter of Earth
in the equator.
At the equator. I think we talked about that.
The
Earth is slightly flattened.
Oblate spheroid.
Yeah,
I think
that's what an oblate spheroid is.
Right,
You're flattened top to bottom.
Okay, yeah.
The sun is also shorter top to bottom than across its equator.
Interesting.
Not by much, but it's measurable. Okay. So when someone asks, what's the diameter of the sun, what answer are you going to give them? Are you going to give them pole to pole? You're going to give them across the diameter? You're going to take the average of those two? I just want you to appreciate that when you look up a numerical answer to a question,
right,
depending on what it's answering, the question might not have an actual answer. We just have to sort of set the rule. The diameters are going to be across the equator for everybody.
What's the diameter?
Oh, that's, you need the high frequency.
Right, you need, that lets them know that it's not exact.
Okay.
Yeah.
So now you say, all right, let's say we do equator. Now you look up at the sun with filters, then you see this sharp edge. All right? The edge of the sun has an edge.
All right.
Okay? But wait. The sun is made of what?
Plasma.
Plasma, it's just gas, basically.
Gas,
okay? Yeah. Plasma gas. When was the last time you saw gas have a sharp edge to it?
That'd be my Uncle Darryl.
When that smell moved across the room, it had a sharp edge.
Sharp edge.
You either in it or out of it.
Man, it's time to go. Yeah.
The spherical ball that is the sun,
right,
the oblate spheroid that is the sun, we speak of an edge, but that's an edge made of gas.
Right.
Okay?
How do you even have that?
That's my point. It's like Earth's atmosphere.
Right.
Where's the edge of Earth's atmosphere? No, there's no edge.
Right.
It's gas that becomes sort of thinner and thinner.
And you know you reached it when you're like...
So when we see the sharp edge of the sun, in practice, we were referring to what's called the photosphere.
Oh.
The photosphere is a layer of the sun's atmosphere, which is the last point of contact with the photon trying to get out of the sun.
Oh, okay.
Okay? And now the photon can move at the speed of light in a straight line. Until that point, it was bouncing back and forth among other molecules and other atoms and other particles. By the way, had that photon been moving in straight lines, you'd be able to see deep inside the sun.
Oh.
That's what light moving in straight lines means.
Right, yes.
Why is a window transparent to you? Because the light moved in a straight line through the window.
Right.
But then I smoke the window. What do you do when you
frost?
I frost the window.
Right.
And now the light, I can't get through. I got to jiggle a little bit. I'll still come through, but I'm not in a straight line.
Right.
You cannot see through the window.
No, yeah, the window's lit up, but you can't see what's on the other side.
The light's coming through, but it's not a straight line.
Not a straight line.
Okay.
Yeah.
All right. So the photon gets to this place, an edge, where it can now escape for free. There's not enough above it to keep bouncing around.
Right.
That edge is the photosphere, and that is our definition of the edge of the sun. That's only using visible light.
Oh, God.
Okay.
I knew there had to be a twist to this.
So we are visible light biased.
Right.
I don't mind that, But don't declare that this be the diameter of the sun if the diameter of the sun is simply what your own damn eyeball can see.
Right. Wait,
Okay?
oh my.
Right? So if you look at the sun in X-rays,
Okay.
it has a different diameter.
Really?
X-ray photons are coming from a different place,
Okay.
a different surface. So we are biased. And I think we need the occasional reminder that we are eyeball biased. Diameter of the sun is where the visible light comes from. And specifically, yellow light. Okay, right in the middle of the spectrum. Red, orange, yellow, green, blue, violet. Right in the middle. Let me keep going.
Go ahead.
There's a layer of sun's atmosphere on top of that.
On top of this photosphere.
Yes. You know what that's called? The corona.
Oh, yeah. Okay.
That's part of the sun.
That's part of the sun.
Why is your diameter not including that?
Right.
That's part of the sun. The corona, depending on where the sun is in its cycle, can be really big or really small. So that changes on an 11-year cycle. But wait, the sun has a magnetic field that extends beyond the corona.
Right.
That's called the magnetosphere. Shouldn't that be part of the diameter of the sun?
It's part of it.
Like part of the sun?
It's part of it.
All right?
Yeah.
All I'm saying is, if you seek the truth, my son, be aware that the truth has many faces. One face may deceive you into thinking that it is the face of the answer to that question. Let you not be blinded by how authentic its truth may seem, because others will be speaking their truth quietly and clearly, and you must listen to them as well.
Do I have to snatch a pebble from your hand now?
Go ahead. Snatch the pebble from my...
Wow, you got some quick reflexes, man. All right.
You do it. You do it.
Oh, snap! You have some really, like, uncannily fast reflexes. Like, there shouldn't be. Whoa!
You are not ready, my son. Come back another time. Okay, one last fun fact about the sun.
Okay.
All right. If we're about 8,000 miles across,
Right.
if you look up the diameter of the sun, it'll give you something like 864,000 miles, something like that.
Jesus.
Okay? All right. So now, let's round that down just so the numbers come out fun. Call it 800,000 miles
it's
across.
100 times bigger.
It's 100 times
100 times.
100 times across. So you can take Earth
100.
and position it 100 times back to back, belly to belly, and you'll span the width of the sun.
Wow.
Okay, 100 times. Now, by the way, that's about the size of sunspots. So the sun has blemishes larger than Earth.
the Earth.
Just so you know.
Jeez.
All right. So now, if it's 100 times across, that means it's also 100 times deep.
Deep. Yeah.
It would be 100 times top to bottom. So how many Earths could fit
Can you
into
just
a hollow
pour
sun?
into the
Pour
sun?
into the sun.
That's 100 times 100 times 100.
Give me what that number is.
100 cubed.
Thank you, Chuck, for that precise response. 100 times 100 is 10,000.
Right. And
100 times 10,000 million.
And then?
If that's it. I did it 3 times already.
Okay.
It's a
Right.
million. So if the sun were hollow, you could
You
pour a million Earths into it
Wow.
and still have room left over. Damn. Yep. Yet, for millennia, people were walking around saying the sun and the moon were like the same thing on the sky, and we're the center of the universe. If you read Genesis literally, the Earth was created before the sun and the moon. And when we came to these realizations over the millennia, over the centuries, it was like, no, we're not making Earth first and then assembling something a million times larger and have it orbit the Earth.
Right.
That ain't how the universe
Yeah,
works.
it doesn't, yeah.
That ain't how that goes.
We're not that special.
All right, Chuck, that's it.
There you go.
That's all I got for you.
Well, the most impressive thing about this explainer is your freakishly fast reflexes. I have to say. It makes no sense at all.
All right, there's been another explainer for Star Talk. This one, what is the diameter of the sun? Until next time.